In this video we're going to discuss a problem in which we find the integrals of 1 divided by x squared root 1 minus x. And as you can see, there's an extra dx that I've written here because we already have the dx on top. Even if you write it here, it kind of multiplies the numerator 1, right? So 1 dx is enough. But anyway, so now how do we find this integral? First, take a look at 1 minus x inside the root. We need to get rid of the root, right? So let's have a u substitution such that u squared is equal to 1 minus x, right? Because this way you will have simply u, because u squared will be onto the square root, right? So x, if you solve for x here, you will get u squared, 1 minus u squared. And thus dx will be negative 2u du. Right? If you differentiate both sides. So now you're ready to substitute. Negative 2u on the top, and we're going to write du in the middle. Then x is going to be 1 minus u squared, and then this part here is what? So 1 minus x square rooted gives you square root of u squared, which is simply u, right? And then du. Right? So then we have what? We can place negative 2 outside. We'll have u over u minus u to the third du, distributing, right? Then minus 2. So now you can factor out the u, right? If you factor out the u, everywhere you will see one, the factor of, by one factor of u less than there were, right? So that means there will be no u on the top, there will be 1. There will be no u here, there will be 1, and there will be u squared, right? Reduced by a factor of u, right? Like that. So now this is familiar, right? So we're going to have negative 2, 1 over, you can factor this, 1 plus u, 1 minus u du, right? To make it like that. So now this calls for integration by partial fractions, right? So you know that 1 over 1 plus u, 1 minus u can be expressed as a over 1 plus u plus b over 1 minus u. Multiplying both sides by this denominator gives you 1 on the left side, and then this goes away, but this becomes multiplied to a plus b. This goes away, but this is multiplied to b, right? This factor, right? So now comparing coefficients, starting with the u to the 0th power, means we will have 1, because that's where the u is to the 0th power, right? Just the constant. And then a multiplies the 1, right? Because we're talking about constants, right? So a times 1 is a, plus b times 1 is b. Now u to the 1st power, there's none on the left side, so 0. There is u to the 1st power, right? So negative a, right? Plus b, b times u, plus b. So now what happens? Adding both equations, these two equations, eliminates the a, right? 1 plus 0, 1, and then gives you 2b. So that means b is 1/2. Using this equation, we know that since b is 1/2, a must be 1/2, so that the sum is 1. A is 1/2. So as a result, the integral becomes this. So instead of that, we have this now, right? What is a? That was 1/2, right? So 1/2 over 1 plus u plus the b value 1/2 over 1 minus u du. Right, so then the 2's cancel out, but there's a negative, and using the substitution one more time, you will see that you will get to ln of 1 plus u, right? So minus ln, and use the absolute value, of course, because the inputs of the ln's cannot be 0 or negative, right? It has to be positive. That's why we need the absolute value bar. So negative ln of 1 plus u, and negative comes from this sign. And there will be one more negative sign, but keep in mind there's this negative, but there's also the substitution right, for the denominator, which gives you the second negative as a result, right? So plus as a result, plus ln absolute value 1 minus u plus a constant. But you're not done, because you need to express this in terms of x, right? So let's start with the positive ln. ln 1 minus, what is the u value? U was this whole thing, right? Square root of 1 minus x, because u squared was the inside, right? So square root 1 minus x, absolute bar close, minus, now we're going to put this one, I just made it in order with the plus, the positive coefficient, and the negative to make it look better, right? 1 plus the u, and what is the u again? This part, right? The whole square root. 1 minus x, absolute bar close, plus a constant. And keep in mind that you can express this as ln absolute bar, right, of 1 minus square root 1 minus x divided by 1 plus square root of 1 minus x, right? Keep in mind that this is the equivalent, right? This is the property of the logarithms, right? So when you have the input of the logarithm a quotient, you will take the ln of the numerator and subtract the ln of the denominator, and that's the equivalent, right? You should know this. If you don't, please review the logarithm property so that you're sure that you know. Thank you so much for watching. Now there's one more constant, and see you in the next video.